Today's project is measuring the speed of a dog. And I want to talk first about the design of the project before we look at any of the code. And what I'm using are 4 microbits with 3 battery packs and 1 power bit. The power bit is going to be on our dog. And I've created this from an old collar. It has a place where I can put the microbit in and keep it safe. So the design is a network of 4 microbits communicating over the radio. 2 of the microbits will function as a start and stop, or start line and finish line locations. This microbit will be with our dog, and this microbit will be controlling the whole process. And one of the first things we need to do when we're designing something like this is figure out what the protocol between all 4 microbits is going to be. And a protocol is just a set of instructions that determines how to interpret what we're seeing. One of the most popular protocols here in the United States is 1 if by land and 2 if by sea, used by the colonies. Massachusetts has a colony. Paul Revere and his ride to warn the colonists that the British Army was coming. Another protocol is TCP, Transfer Control Protocol, and another protocol is IP, Internet Protocol. And TCP and IP determine what that stream of ones and zeros means when we get it on the internet. It turns it into movies that we can watch. It turns it into pictures that we can see. All of that is based on a protocol. So we're going to set up a protocol for our little tiny network here. And what's going to happen is when I push the A button, this microbit is going to send out the message start. And when this sends out the message start, all of these microbits are going to do whatever kind of initialization they need to do, and then respond back for each of the 3 microbits. This microbit will then display a check mark saying we've heard from all 3 microbits and they are working properly. This button B is going to send out a message stop. And when that happens, the microbits will stop doing what they're doing, and the dog bit here will send us back a calculated speed for our dog. So let's turn these on. Now this microbit says S. I don't know if you can see that because of the way the camera strobes, but I'm going to push the button to turn it from a start to a finish. It runs the same program. I'm going to turn on my dog bit. And I'm going to turn on my control. Smiley face says it's okay. And when I push the A button, these all respond by saying check mark. And once they respond, I get a check mark here. This microbit shows when I'm receiving a message from these 2 microbits. The left is start and the right is stop, as finish, the finish line. So what happens in our design is when we push the A button, these microbits begin broadcasting a low power signal. This microbit begins reading those low power signals and is looking for the maximum strength signal. And when it gets the maximum strength signal, it's going to save the clock time of this particular microbit, the uptime, if you will. And when it receives the finish line, it's going to save that time as well. And when you subtract the two, you get the time between the two beacons in milliseconds. So let's try that. I'm going to move these apart a little bit. Push the A button. Okay, everybody responds. Everybody's good? All right. So as our dog runs by the beacon, this microbit is looking for the maximum signal, which it reaches right about there. And then it runs more, and it reaches the maximum signal for the finish line, which is right about there. So now when we push the B button, we get 0.209 miles per hour, which makes a lot of sense. Okay, so that's how it's going to work. Now, we need to verify that the numbers we're getting is at least somewhat correct. So what we're going to do is we're going to move this microbit over here to the 3-foot spot. We're going to move this microbit over to the other 3-foot spot. So 3 feet apart. On our dog bit, I'm going to say, let's set this to 3 feet using the A and B buttons, 3 feet. We're going to put our dog bit on our robot, which we've pre-programmed to follow this line from start to finish. And now we're going to push the A button. So it's got a smiley face now. Okay, they've all responded. Now let's start up our robot. Now, I have previously used a stopwatch to calculate what that should be running at, and it came out to about 0.466. So let's see what our system has calculated. 0.467 miles per hour. So that is how we know that we've got it right. We've measured it against a different amount using a stopwatch, done the calculation by hand separately, and then compared that to what our system here is telling us. And it comes out close enough. Okay, so that is how we've designed the system. And now we're going to look at how we can code that up